that will start us live on there. My children are making noise in the background as well, which is, par for the course. So thanks very much for coming along to Nuts IoT. Before we get going, we've got this Be Kind conduct, code of conduct that we run here. So there's a lot of words on there, but basically just be nice to people. But if you feel as though you're being made to feel uncomfortable by anyone, then the first place is just send me a private message in the chat here on Zoom. But you can also contact me on Twitter if you like, at Pete_codes. Or if you go to that bit.ly just there, then there's an email address for me there too. And we'll take that seriously and follow it up and keep you a part of that process. So do be nice to everybody. Onwards from that, we've got a bunch of sponsors here. We would normally, of course, as I say, be thanking Rebel at this point. We'd be sitting in their offices and eating their pizza. But as we're not doing that, then my company, PJG Creations, I pay for the hosting for the website and organise it. So that's why I've put that on there. But Tech Nottingham, who I'll talk about shortly, they've bought us a Zoom license, which is what you're joining here through today. So thanks to them for that. JetBrains, they're sponsoring us a 12-month license for one of their products, which I'll talk about in a minute. And stickers, well, they're still making us stickers, but you can't have them because, I can't feed them through the webcam. So if you tweet on the hashtag NotsIoT tonight, then one lucky person will win a 12-month license to one of the JetBrains products. JetBrains make developer tools for developers, so things like Rider and IntelliJ and PHP Storm, WebStorm, and things like that. So that's a great thing to do. So go ahead and hashtag NotsIoT on Twitter, and we'll draw a random person in the next few days. Tonight we've got Andrei Podnozov, and in fact we've also got Anton Kishenenko? I should have asked you that before I started here. Kishenko. But
close enough.
Yeah, it was terrible. Apologies.
No worries.
So yeah, we've got two for the price of one. I probably should have taken the time to change my slide there as well, so apologies for that too. They'll be talking about Azure Digital Twins, so that's going to be interesting. Coming up next month, we've got Mike Pound, who I spotted. He's a part of he's actually a Nottingham University professor, but he's also a part of a YouTube channel called Computer File, which is a sister channel to Numberphile. So go and check them out. But he gave a little video there about how you can use modern technology to crack the Enigma machine encryption. And actually, it's not as easy as you'd think. You'd think it would be easy to brute force it these days, but it still isn't easy to brute force that. So he's written some code, and he'll come along and demonstrate and talk about that. So really looking forward to that. It's going to be really interesting. As I mentioned earlier, on Monday coming, we've got lightning talks at .NET Knots. So if anybody here is interested in coming along and giving a lightning talk, then by all means do. We're a very friendly audience over there, and you can talk about anything. It doesn't have to be .NET related. There's also my IoT Live. Cliff Aegis and myself run a Twitch show on the Azure-ish Live Twitch channel. We've just been running through a workshop with Paul DiCarlo from Microsoft, getting an NVIDIA Jetson Nano up and running, doing AI and ML at the edge using IoT Edge as it happens. So that's been quite interesting. And as I say, that's part of the Azure-ish Live Twitch channel, and we have an Azure-ish Live show every other Wednesday, I think it is, but we're on a bit of a break at the minute. And you've got three of the original AZ220 Microsoft IoT Developer Exam authors on this call, two of which are presenting and one of which is talking to you now. But if you want to learn a little bit more about that exam, then myself and a few other authors have created a set of Pluralsight courses to help you do that. So go to that short link there and check it out. I've also got, unless they've expired, some 30-day full access Pluralsight licenses. So if you're interested in those, then just hit me up in the chat and I'll send you one of those across. And there's also the Agile Engineering podcast that you can go and listen to. I mentioned Tech Nottingham earlier. They're a fantastic local community. Obviously, everything's online at the moment, but you can go and join their Slack. And there's channels in their Slack from everything from .NET to IoT through to just counting up in hex. Anything you want to do in there. So With that, I will pass you across to our speakers for tonight, Andre and Anton. Thank you very much.
Hello, hello.
Hello.
Let's see. I'm gonna get my screen projected. How is it looking? Looking good.
I'll tell you. Looks good to me.
All right. Hello, everybody. The title of this talk today is using Azure Digital Twins and IoT solutions. So this is going to be a rather technically focused talk, focused specifically on Azure Digital Twins. I think I don't want to go too much into the kind of digital twins in general, because there's a lot of material there. There's a large body of knowledge. But one, I already done a talk on this last year, and two, Azure Digital Twins service is, for me as an IoT solution architect, of course, is very interesting from the technical perspective, first and foremost, how I can use it in my solutions, how I can bring additional value to my clients using Azure Digital Twins. So let's see, let's dive in. Let's see, how can I derive this? About the speaker. So this is me. This is some bragging points about myself. Well, okay, let me go over this a little bit. I'm an IoT solutions architect. I work at Luxoft. We are a DXC technology company. I'm located in Seattle, Washington. I've worked on IoT solutions from many different domains, and I am a cloud solution architect. Okay, enough bragging. My co-host is Anton. Anton, do you want to brag about yourself a little bit?
Sure, I'll try to keep it brief. I'm just gonna pop my face on the camera so you guys know I'm a real human. But I'm a bit constrained on bandwidth, so I will turn it off. A few points about myself. I'm also a cloud solution architect. Currently work for make air quality sensors for forced air systems. So residential homes with HVACs. That's my primary job. And then I also sit on the advisory board for Suncatch, which is a startup down in Denver, Colorado. And my technical demo, my digital twin demo, is going to be focusing on their product, which is a concentrated solar thermal collection system. Yeah, also was involved in certificate program, well, writing questions essentially for the Azure IoT certification exam, which was a really fun experience where I got an opportunity to meet Andre and Peter. I think it's good enough.
Okay, sounds
Andre,
good.
back to you.
All right, moving on to the agenda. Well, I just said that I don't want to talk about digital twins in general, but I think we need to put this into an overall context a little bit. So if you are not familiar with digital twins whatsoever, I will start with discussing just some basics of what digital twins are before we dive into the specifics of the Azure Digital Twin service and its features. And we will see the demo by Anton, and then we'll discuss some kind of the outcome thoughts based on what you learned today. How can you derive value from Azure Digital Twins? followed with a Q&A. So audience assumes technical audience today. I will assume that you are familiar with Azure IoT already, that you're familiar with Azure services. So that's why we're not going to dive too much into that, but we will always consider Azure Digital Twins in context of an overall IoT solution. All right, let's start with definition. Digital twin is a virtual representation of a real-world entity. That's my definition. I'm sticking to it. So, entity, real-world entity. What kind of entity we're talking about? It can be physical object, like a connected car or a smart building. It can be a non-physical entity, for example, a company or a government body. It can be living entity. I worked on a smart cows project, for example. It can be a process. For example, a digital twin of a moon flight or a digital twin of fracking drill, right? It can be an environment. Air quality monitoring system that Anton just mentioned is a good example of that. So I want to address right away this a little bit of a naming confusion between digital twins and device twins in IoT Hub. They are not related. I know it's unfortunate. Naming causes some confusion for some people, but I mean, hey, what do you know? There's only this many words in English language, right? And people work hard on that marketing, I'm sure. So, but let's see. Now that we understood the entity part, okay, let's see, let me get the light. Now we understood the entity part. Let's understand what, so entity we covered, but virtual representation, what is that representation? So when people hear digital twins, the first image that comes to their mind, it's like a 3D wireframe model, right? Or maybe what other representation? Maybe like a physics simulation of some kind of jet engine and complicated fluid dynamics happening there. Or maybe it's an ML model. So what kind of representation? Well, it can be any and all, depending on our business objectives. So for example, let's say we have a fleet of self-driving taxis, and we want to create a digital twin that will help us optimize customer satisfaction of our taxi service. In this example, a 3D wireframe model of individual taxi cars may be not relevant, right? But of course, if you're talking about smart spaces, optimizing a building for occupancy, then yes, those blueprints and layouts of floors will be highly relevant. So, and then what are we representing there? A few things that I'm listing here, starting with context of an entity. So context, so imagine you're an IoT hub. You have a million devices there. They're all streaming their telemetry. You can view their property. That is kind of hard to navigate, right? So we need to put these devices in context, like where are they located? What is located around them? What kind of interesting behavior well, okay, behavior, we'll get to the behaviors later, but context help us put IoT data into a big picture. And then current state is what we will be representing. I think that's pretty obvious what's happening right now with the device and the twin. And lastly, the behavior. Behavior is what it's like, how can we predict what will happen with this twin based on the current state? So behavior here has this predictive aspect, and this is very important, and we will see why. So, and by the way, as we're talking about context and the current state, I keep mentioning the device, but based on our previous examples of entities, those entities may be non-device entities. They may be even non-physical entities. So think about context and state and behavior of twins in a more generalized sense. So like we used to thinking about device twin state related to IoT devices. So now we're thinking about digital twin state of a more abstract entities that those digital twins represent. So now, like I mentioned, behavior has the predictive aspect. So let's see why this is important. So this next slide has this picture. I'm sure it's familiar to many of you guys. Things, insights, and actions pattern. So digital twins, the digital twins are situated here in the middle section. They belong in the insights area because they help us convert data to insight, convert information to knowledge and to wisdom later on. So, okay. Now, this is just a general, very quick, a few conceptual words about digital twins, but now let's see how do Azure Digital Twins help us fulfill our solution needs. Let's go over the capabilities of digital twins. So several main capabilities that I'm listing here, starting with digital twin definition language. This is this is how you define twin schemas, and they are also called models, DTDL models. It's just a bunch of JSON. It's a special flavor of JSON, and DTDL gives us some additional useful features with regards to those schemas. Those schemas are validated. This means that Azure Digital Twins ensure that the set of schemas that you're giving it are consistent, those models. It offers schema versioning capabilities, and it also has a few sample ontologies for those models from a couple of domains, such as smart city and smart buildings. Next, twin graph storage is the next capability of Azure Digital Twins. This is where you actually keep that current state. And so the schemas from the previous point are actually applied to the twin graph storage in the sense that Azure Digital Twins service enforces enforces the schema on your data. strongly typed graph is what you get. Next, it has query capabilities to help you search data in that twin graph storage. And this is based on SQL syntax. So it will be kind of easy to learn if you're a little bit familiar with SQL. Next, Azure Digital Twins use external compute model. And so what it means is the behaviors that I mentioned on the previous slide, Azure Digital Twins does not have behaviors inside of it, but it allows you to bring in your own compute to express those behaviors, such as it could be like Azure Functions, could be your like microservice cluster, whatever you want to do. And Azure Digital Twin will give you the hookups to that compute by the virtue of event routes. And then, of course, like we are used to with all the Azure services, you get a rich tool set, such as Twins Explorer tool, model schema validator, various CLIs and SDKs and REST APIs and whatnot. So I think before we go deeper into talking about the twins, let's watch a demo by Anton that will help us put a lot of these things into perspective. I'm going to stop sharing. Anton, you can take over.
All right. Share the screen. Can you guys see it?
Yes, thank you.
Excellent. So, yeah. On my connectivity right now, so we'll go a little slow, and if I'm being interrupted and unclear, please just tell me so, and I'll repeat myself. When we were discussing with Andre, what would be the best demo for you guys to show real world scenario and highlight the capabilities that Andre, which is the main components of Azure Digital Twin offering. We have TDL, we have Twin Graph, we have query capabilities, toolset. What came to mind actual current need that I'm trying to design a solution for the real technical problem that is faced by the Suncatch, which I mentioned earlier. It's a concentrated solar thermal collection system. Components.
Anton, sorry, breaking up pretty badly. How is it for everybody else?
Yeah, it's breaking up, I'm afraid.
Anton, can you try maybe dialing through the phone?
Yeah, guys, absolutely. Give me just one quick moment. Meanwhile, can you share the slide with the component diagram?
Yeah, I'll talk to the slide in the meantime. Let me do that. So that okay, let's see. How do I do that? Like this here. I wanna give it a full screen. Okay, present to view. Okay, that's good. So I'm gonna share Anton's diagram. Okay. Do you guys see that? Is it coming through?
Yep,
okay, great. So the system that he's currently working on, and this is inspired by a real system that he is helping develop. The goal of the system is to collect solar energy through this solar collector and store it, the thermal energy in a thermal tank. So it's a slight twist on the green energy in the way that it's not collecting electricity, it's collecting heat, right? But I mean, energy is energy. There's lots of uses for heat in both residential and industrial environments. And so this is his architecture here. Basically, so there's the tank that collects the that stores the heat in the form of like heating up some thermal material, and the collectors feed the tank with some kind of pumped liquid. So these mirrors that they heat up the, well, anyway, there's the hot liquid circulating between the collector and the tank. And you can have multiple solar collectors, these mirrors, feeding the same tank, depending on how you need to size your installation. And then, so this is on the supply side, and on the demand side, this energy from the tank can be spent in, let's say, in a residential home on, doing either warming and heating of the home, or anywhere else where you need hot water, like washing dishes or doing the laundry. And of course, in industrial environment, there's even more usages of hot water. Like, think about a farm scenario. They always have a need for hot water for like washing animals and heating and whatnot. And so this load manager is a component that kind of governs, monitors, and keeps track of spending the energy from the tank, because it monitors the consumption. It knows how to predict future spend, and it also collaborates with this other component, weather station, that gives us weather prediction. This part, based on the information from this part, the system knows how much incoming energy it can expect from solar collectors and how much upcoming demand does it have on the load side. And so it's responsibility of the load manager to balance these two. And of course, the ultimate goal is to try to optimize the electricity usage from the grid so that we result with kind of a cleaner, greener, and more environmentally friendly system. Okay, let's see. Anton, are you back? Okay, well,
can you hear me better now?
We can hear you excellent.
Seems to be, although how that copes when you start sharing your screen, we'll see, but it certainly sounds better.
Shall I stop sharing?
Yep.
I'll stop sharing.
Okay. So what you're looking at here is the same representation of those components put together into digital twins. And so I'll start with just going down the component list that Andrei presented in the previous slide. Hear me okay still?
Perfect now.
Sounds good.
Beautiful. Yeah, so let's dive into it. First component was DTDL, right? We want to define are entities. We want to have a virtual representation of those entities. And the way we do it is by simply defining JSON that represent a specific entity. By the way, in terms of the tool set that's available for you guys, you're looking at a digital twin explorer. Azure provides this as an open source project. I'm currently running it locally on my dev station, but you can host it. And I personally really like it. The tool is under active development. New features being added. In fact, this version is a bit outdated now. So very handy to have this visual interface to interact and prototype digital twins. So on the left here, you see models, which is the DTTL definitions. I'll show you one of them as an example. So this is this strongly typed schema. You have properties, you have you can add telemetry, which doesn't have a lot of functionality right now. Let's say, what properties do I have here? I have properties like mode, which we'll be exploring in the, like this is going to be the focus of my demo. What mode is on the solar collector, and actually a little bit more of context. The reason why I even landed on digital twin as an interesting fit for a technical problem is because what we're trying to solve is the fact that solar collectors are at risk of certain weather conditions where the primary task of solar collector is to track sun, to focus the sunlight on the heating element, and but it goes in conflict with the state where if we have really high wind and the current position of the parabolic mirror is facing the wind, it creates a lot of shear load and can potentially break the system. So what we recognized is that in order to have this predictive maintenance or other safety mechanism, it's really critical for us to know the state of the wind. And if the wind is above a certain threshold, we should prioritize putting the mirror in a position where it's least susceptible to damage in high wind conditions versus in autonomous mode where it just needs to track sun position in the sky. Right, so this is how I'm representing that mode it's an enum that has two states. Auto representing a state where it's tracking sun and doing its autonomous harvesting function, and safety is a mode that represents it represents the state where the position of the mirror should be essentially it's horizontal, but physically it's least susceptible to high winds. We also have relationships that essentially describes the graph function of all of your entities, how they are related. And it's really important to define this correctly, give it a name. So in this instance, I have relationship between my solar collector to the weather station, and I just give it a friendly name. Names are important when you want to traverse your graph and find these relationships when they are important for you to take certain action on the inside. Close that and move on. So this specific chart is showing you model graph, which is all of the types of entities that you have in digital twin and the relationships between them. Weather station represents that weather service. A good piece of insight for me was that it's not necessarily, digital twin does not necessarily map to a physical entity. It doesn't need to, but weather station is, say, it could be potentially a physical entity. But in my case, it's just a service that gives me the insight on current wind condition. It doesn't have physical embodiment. Solar collectors are those parabolic mirrors. They feed tank. Load manager estimates how much energy tank stores, and also gets forecast from weather station to have this predictive capability that Andre just mentioned, where if I know how much sun irradiation I can expect for the next couple days, it enables my load manager to have this predictive capability to say, hey, I know the tank is pretty warm. I know your average daily consumption, and given the forecast for next 2 days, you're going to have an excess. So maybe a good time to start to take on some activities that require a lot of energy, but they're not your day-to-day normal loads. I think it's better to leave questions for the end of the demo, but if something is something that you want to touch on, please feel free to just interrupt me and I'll be happy to answer. All right. So good. So far, so good.
Perfect.
All right. Now let's switch to the twin graph, the second component of capabilities of Azure Digital Twins. So this is where we make an actual instances of our digital twin models. And this would represent, so in case of solar collector and actual physical devices, you can see that I have 3 solar collectors, C1 to 3. I have an instance of tank, and I created relationships between them, right? So just because the relationship is defined in the model, in actual twin instances, you have to go and manually enable those relationships. The twin graph, another capability that Digital Twin Explorer provides you is the query interface. And Andre will talk about querying language and its limitations later, but it's just there accessible to you. And I find it very helpful when you have when you use Azure have some interesting examples around digital twins where you can load existing twin graph data. When you have lots of entities, querying capability is definitely allows you to narrow down on on large volumes of twins. So the properties of these twins and twin graph actually represent this state of the twin. And in the demo, the scenario that I want you to experience here is essentially what I described, where weather station can produce not a forecast, but the current state of wind. Currently, it's set to 0. I have a certain threshold of 20 meters per second that if the current wind is above the threshold, it should send an alert, a wind alert to the collectors and put them in the safety mode. A little bit of behind the scene, what's going on in Azure. Sorry, kicked me out because I had to switch Wi-Fi. Just briefly walk you through the components of what's happening, which services are necessary, and what do we have running in the cloud to enable this scenario. I'm gonna open you. So I had to manually create an event grid topic, and that is the event mechanism which Digital Twin is using to notify the external compute. In my case, it's an Azure function that a twin change event happened, right? So I have an instance of Digital Twins. Couple plumbing things that I had to implement is to allow my external compute, which is function, to communicate with Digital Twins. I'm just using a managed identity. The function itself essentially is listening on the Digital Twin route. Route is the mechanism how Digital Twins can notify external services that something like the state of twin changed. As I already mentioned, here's my event grid topic. And in routes, I currently say that any twin update let's actually dive into this because this is useful to understand the full capability. Route can be defined as like which events will go into the event grid topic. It has quite an extensive capability for filtering. So in this case, any twin update will be pushed out. But as you're designing your production solutions, you can have multiple routes that filter on a specific, perhaps twin type or specific event from twin. So I was pretty happy to see that it's already available. And of course, you don't want to have just one event stream channel, because then the logic that handles it will be overly complicated. Or at least it will need to be aware of all different types of twins and events that the channel may have. Cool. So that was the plumbing side of things. Over here, I have the function. It's essentially an event handler that performs, that processes event grid events that come from the digital twins. And just briefly on the integration, straight hookup to event grid topic, and then it triggers the function process wind update. So let's take a look at it. I'm going to jump into the live logs just to give you an application logs from the function running. Connected, let's clear that. So what am I going to do and what am I expecting this function to handle? If I change a weather state of the current wind, which would be, let's say, an input from a weather service that tells me your current wind is 10 meters per second. Digital Twin Explorer allows me to actually modify twins directly. So I'm changing the state of the weather and I'm saying current wind is 10. A bit of context here, 20 is the threshold that I have on the function. Above 20 is critical, 10 is within the threshold limit. I'm gonna patch it. So I'm saving that state to the weather station digital twin. And I see that the function processes this event. Twin update processes sync, just essentially spills out the actual message that was sent. You can see that the model ID is weather station 1. It was a patch event with value 10 for current wind. And also that operation on the twin was a replace operation. And the logic of the function handled it. What was happening on the back end is function identified all of the twin relations for the weather station. So it figured out that I have solar collector 1, 2, and 3 connected with weather as parents to the weather twin. And then it simply ran this threshold logic and said, hey, is it above 20? No, cool. Then the mode should be auto. And of course, if I put current wind, let's say we have a new piece of data coming in that updated weather twin saying the current wind is 23. It's another patch. What function did here is it recognized that now the wind is above the threshold, and for all the parents of the weather station, we set the mode to safety. We can actually check that it's happening on the twin itself. We can see that mode is safety on all 3 units. And let's say critical weather event completed, or wind dissipate, we have current wind back to normal, and it triggered change on the mode for all the stations back to auto. So, trivial but very useful piece of functionality that I'm actually going to continue prototyping, and hopefully we'll implement it for the Suncatch solution. I don't want to drag this demo much further to leave you guys more time for questions and discussion of some shortcomings, because there's a few. But final thoughts here is that this demo is not fully featured. It's just the intention was to give you the understanding of some plumbing and what is this external compute means, and how it integrates with digital twin. The last component that I wish I had prototype for you was that I would have another piece of external compute that will monitor twin changes of digital twin changes on Suncatch solar collectors. And once it recognizes that the mode is changed to safety, the obvious next step would be to actually make that change, make either a direct method call to set the state of the device twin. No, sorry, I mean, either is going to be a direct method call to the actual controller on a solar collector and saying, hey, now you should put yourself into the safety mode, or maybe you propagate that through a device twin, right? So that connection to the physical device still requires this additional compute, external compute function. But yeah, in terms of code, I don't know, Peter, Andre, you think this is something that I should just briefly show?
Yeah, let's see the code. That's the most interesting part.
Okay.
I agree.
Cool. So few packages that you'll need to install, mostly digital twin core, your regular .NET HTTP, because you're communicating with the digital twin through APIs, through HTTP client. It's a function that has an event grid trigger, right?
Do you want to zoom in a little bit, Anton? Is that okay? Just zoom in a touch. Excellent, thank you.
So in bootstrapping the function, we have digital twin client. It takes default Azure credential. This is why I showed you guys that I need to set up a trust relationship through a role where function managed identity was granted I'll return to it over here, was granted a digital twin data owner, digital twin data owner role right here. So specific role that is required for your client applications to be able to take certain actions on the actual data twin, so the data plane of the service. Okay, back. Some error handling, and the main body of the function is essentially receives the event grid data message, parses it, extracts primary things like twin ID, and understands what type of operation it is. I'm looping through all types of operations because I'm using an example. And that's another thing to mention here. Azure has quite a few different examples around digital twin that help me put this demo very quickly together. So for those of you who are trying to prototype, strongly recommend to look through digital twin examples, code, and walkthroughs. So I was pretty satisfied with the certain limitation of functionality. At least they have a good documentation coverage to get you up and running pretty quickly. So I'm looking at operations, and let me just go back here. And the operation is, in brief, it's OP in the message body. I only want to respond to operations that have changed current wind. And if it is an operation on a twin that has current wind property, I'm just making an assumption that it's the weather station. And therefore, I trigger the logic that says, hey, first of all, get me all of the relationships for that twin. So for weather station, it's an implicit assumption. The relationship of type wind alert are relationship with the solar collectors. And for every relationship there, I want to compare it to my threshold value. If the current wind was above 20, I'm setting the mode. There is a utilities class, but this is just a little helper class I wrote. Update twin property. Those are all available to you through the digital twin client. And there's just trying to say there's nothing much to see there. There's no magic. It takes the resource ID and sets the property that it can find that matches the string to a safety. One interesting nuance when I was debugging it, a bit of a gotcha. When you're trying to patch a property on a twin, and originally when I created the twin, right, I see that there are default values for the properties, but that's just a function of the Twin Explorer, but the actual property didn't exist. So I didn't have mode set to anything, just that property was part of the model, but the twin didn't have the instance of that property. I was hitting an issue where my function was just throwing an exception saying I can't find mode. And yeah, the gotcha was first you need to set the mode so that property becomes available on the twin before you can patch it to override it with a different value. And this is it. I think I'll stop here, not to be boring. I'll be happy to answer any of your questions, guys.
That was really interesting. There's a quick question from Chris Claxton in the chat. What happens when the weather sensor fails, connection drops, and things like that?
Great question. There is no and a very practical one. And it also falls into the domain of the consideration, like why digital twin versus just having controllers on solar collectors being hooked up directly to some kind of a streaming service. And I don't have an answer. I just know that it's a supplementary capability that I think digital twins is a very good technical implementation for. You can have redundancy, you can have multiple weather controllers. In fact, because it doesn't necessarily represent a physical entity, it's just a twin that gets data from the service. You can have multiple services, right? And have some type of, again, redundancy on that end. That's how I would implement it, but valid concern.
Cool.
All right. How about I give the floor back to Andre and stop my sharing?
Yeah. Do you need to hop off the call now, Anton? Have you got to disappear or?
I have 5 minutes for extra questions, and then I'll have to bounce.
Okay. Well, I mean, if nobody else has got any questions and Andre's going to carry on, then obviously you can feel free to disappear. But just bear in mind, people, that Anton's disappearing now. So if you have any burning questions, then he won't be around at the end to answer them. It does say
or email or LinkedIn. I'll be happy to share my little journey into digital twins in Azure.
Sounds good. Alan Buxley says that he was going to ask a similar question. If the wind sensor fails and thus reads 0, require multiple sensors in that location, might even use the twin as a checker, would be able to detect failed sensors. Chris Claxton has asked, can you implement timeouts and fallback actions if no data is received?
Absolutely. And in fact, if you think about, like, if I were to describe the current capabilities of the controller, which I was involved in actually writing firmware for, like it's fully autonomous. It has a lot of, like, I had to implement a lot of control logic and state machines in order to handle all the scenarios where you have essentially, you need to put in the brains for the tracker to decide the priority of various factors that affect how it operates in autonomous mode. So yeah, it's interesting, but a deeper discussion. So let's leave it to a different occasion.
Sounds good. Yeah, thank you very much then, Anton, and thanks very much for coming along, and hopefully we'll catch you again soon.
Perfect. Well, it was a pleasure to join you guys and have this conversation. All right. Cheers, everyone. Bye.
Thanks,
Thank you, Anton.
Bye.
Okay, let me put up the screen again. Let's see. Okay, just a little bit with Zoom confusion. Very good. So yes, that was the demo that we saw. Thanks to Anton for this walkthrough. And now let's look at some additional considerations that you need to know when solutioning with Azure Digital Twins. And of course, an important consideration is pricing, because as a solution architect, I have responsibility to my clients to give them the functionality they need at the best price, right? So pricing is always an important consideration. So this is just a table that I grabbed from Azure Docs. And so pricing here is on the serverless model per million messages. And so everybody loves serverless, right? So that's good. And except, let me just clarify this. What does, like, this query unit? Yeah, let me just go through the table. So messages are the events that are emitted into the event route. Okay, let me get the cursor. Messages are events that are emitted into the event route. That's the place where Anton hooked up the function to, right? $1 per million messages. Operations are any calls to Azure Digital Twin API. And query units are additional charge for calls to the query API. Let me show you this, the various APIs that Digital Twins have. That's probably a good, yeah, let's see. Okay. Oh, so this is Anton's code. Various APIs that Digital Twin has. So this is the SDK that, so this is the REST API that we're looking at, and breaks down into control plane calls and data plane calls. And the data plane calls, there are some management APIs for models, and then there's queries to do search in the twin graph. And then there's twin operations to do individual operations in the twin. And so any of these operations will incur operation charge, but query operations in particular will incur the additional query charge. And so the operation charge is pretty straightforward. It is billed, an operation is 1 kilobyte of the return response. So if your response is 10 kilobytes, you'll be billed for 10 operations. But query units is not as straightforward. There's no simple formula to estimate to calculate the query units, but any query call will return the query charge. And I can show you how it looks. So for example, if we go to the Digital Twin Explorer, this is a sample graph that comes with the Digital Twin Explorer that I loaded here. It's a power grid graph. And so on this graph, as we run a query, so like, for example, this query, I can run this query and I want to see what was the query charge. I'll show you a little trick. I'll go into developer tools and I'll watch this trace. And so this is my query call. And I look at its headers, and one of the response headers is called query charge. And it tells me that I was just charged 8.57 query units for this query, in addition to the response charge. So this is my response, right? That describes all the entities that the query returned. This response has a length of 11,238 bytes. So I was billed for another 12 units of operation charge. So 8 query units and 12 operation charges. So they cost, you know, different money. Operation units is slightly more expensive than the query units, but the query units, you'll run up a lot more of them. So like, for example, let's get a sense of what kind of query charge can a simplest query give us. So like, for example, I'm gonna query just for one individual twin with an ID of PCT. It's one of the twins here, it's this one. So I'm gonna run, okay, this was the call to PCT that I just issued. And notice that when I examined the PCT twin individually, I did not get a query charge because it did not use a query for that. Instead, it used a get by ID operation. So you don't get charged for that. But if I use a, okay, so let's just see the response length. Okay, less than 300 bytes. So all we were charged is a one operation charge. But when I run a query, so here's my query, I did get charged 3 query units in addition to the same charge for under 1 kilobyte response, one operation fee, right? So, and it scales up from there. Like, for example, if you want to build a slightly more realistic query, because you're probably never gonna just query for one guy. Like we saw in Anton's example, what he's querying is for relationships of this particular twin, right? It's children. So, and I'm gonna show you a query that does that. So here, okay, let's look at that. we accomplish that by using the join. So, and the join in the digital twin is kind of like a self join, right? So we join the digital twin graph and we give it an LEST. We join it with itself and we give it LESC for children. And we join it along a relationship called feeds. Because we know that this PCT substation, right, feeds into other like parts of the grid. So let's execute that query. And in fact, we see that it feeds into this generator. Let's examine the query charge on this one. Okay, where's my latest query? This is my latest query. And the query charge is 18. And the operation charge is still under a kilobyte. 18. From 3 to 18, right? That's pretty steep. What happens if we join through 2 joins? So I'm joining through one relationship on children, and I'm joining on second level of children because the graph has the feed relationships throughout. Let's run that. My latest query is this one. 29 query units, almost 30. So that's pretty steep. So Digital Twin service supports up to 5-level deep join. So I'm gonna go 1 more level deep to the 3rd children. And I'll run this query. I just want to see how the query charge scales. 40. So essentially, every additional extra layer adds kind of a 10 query units in this very simple query. That's interesting because even when we loaded the full graph, we got charged only 8 query units when we loaded everything, right? But when we loaded this simple chain, we got charged 40. So this is kind of an indication to us that maybe it needs like a better indexing internally, but we don't have any control over that indexing, as opposed to like you can tweak the indexing in Cosmos DB, for example. Maybe it doesn't have any indexing whatsoever. So it does maybe just a flat scan of everything. I don't know. I'm speculating. So, but this is what I wanted to tell you about pricing. And since I mentioned Cosmos DB, let me just bring up Cosmos DB pricing here just for comparison. So this is also a serverless option for Cosmos DB pricing, also per million request units. That's 25 cents per request unit. So you can see this is 10 times less. So I have to qualify this, of course, because request units in Cosmos DB, a read operation is 1 request unit, but a write operation is about 6 request units. So so for read operations, Cosmos DB 10 times cheaper, but for write operations, it's only 1.5 times cheaper. But if you start doing any queries, queries in Cosmos DB are a lot more efficient. They don't scale nearly as, as sharp. They are sublinear. So, and this is a serverless model. If you switch to provision throughput model in Cosmos DB, it's going to be another 10 times less expensive. So we're looking at price difference between Azure Digital Twins versus Cosmos DB of 10 to 100 times more expensive. This is where I jump into my next slide, ADT shortcomings. High pricing is my number one complaint or wish list. High pricing. I think it's not as bad as it sounds, because traditionally we've seen that with many Azure services, they come out with a pretty high pricing when they're new, and then they're drop gradually. So this is temporary. I'm sure it'll become less expensive. But let's run through my the rest of my complaint list. And so let me just give a disclaimer. These are my own opinions, right? This is not, I'm not affiliated with Microsoft. I'm not a Microsoft hater. I love Azure. But like I said, my responsibility is to my clients, and these are some points that I will have to carefully consider before using digital twins in my solutions. My number 2 complaint is enforced schema. Why am I complaining about this? If you read Azure IoT reference architecture white paper, one of the recommendations there is schemaless storage for IoT data like Cosmos DB. And schemaless gives you certain benefits compared to strongly typed schema like SQL Server, and that's one of the reasons why a SQL Server is not recommended for hot date storage. I mean, you need to validate schema anyway, and you will do that in your code anyway, right? Because it's kind of irresponsible to write whatever that you don't know what you're writing, right? So you will validate the schema in your code anyway. But do you actually want the storage layer to validate your schema as well? That is a question, because I think that will create just extra friction, especially the fact that you will have to version that schema as well. But again, I think there's a simple solution that could be for this bullet point is if we had the schema validation library that we could just use in our code and don't have the schema forced upon us in the storage layer. I think that would be easier to work with. And I'm not aware of such library, but I'm sure it's if it doesn't exist yet, I'm sure somebody's going to write it very soon, either Microsoft or some third-party library. Because I mean, it's kind of conceptually similar to like we used to have XML schema validation back in the day, if you remember. So, okay, next bullet point, no internal compute. So, those who remember back in the day of previous beta of Azure Digital Twins beta 1, it did have internal compute, and it was a more kind of complete solution that had state and behavior together. In this version, Microsoft made compute external, and there are some good reasons for that, like easier debugging, but detaching compute from state changes has certain disadvantages as well. Like, for example, you're now running a risk of a race condition, because your change handler is decoupled from the change itself, and you also don't have any ordering guarantee in the delivery of those events, because Event Grid doesn't provide order guarantee, for example, and neither Event Hub, if you think about it. So if you're in a situation where your digital twin is experiencing a lot of activity and a lot of changes, so race condition is something to think about, and basically, more generally speaking, an issue of consistency of your updates and event handling. I think a great solution here would be if Azure Digital Twin service brings back the internal compute. I think that would be an awesome service. Kind of like, that would be kind of like an actor model framework, if you're familiar. And in fact, if my understanding is correct, Digital Twins service is implemented with Orleans actor framework. So here's one of my wish lists. Let's bring back internal compute and see how it can get a lot more interesting. Next, querying capabilities are pretty weak if you compare it with the full-featured graph querying language like Gremlin that Cosmos DB uses. There's really no comparison there. Like, I mean, in Gremlin, you can express pretty much any query with group bys, with lots of functions. Here, it's pretty limited. But I mean, my wish list would be to support a fully featured graph querying language, right? In Digital Twins. Although at that point, you're gonna start wonder, are we re-implementing Cosmos DB graph at that point, right? So I need to look at the value proposition of that. Next bullet here is missing features. So some of the features of Digital Twins are currently not implemented, such as DTDL has commands, for example. So we didn't go over the DTDL, but let me just show you briefly. Okay, so DTDL language. DTDL language specification is hosted here in the GitHub. And so Digital Twin definition language model file can consist of several parts. Interface definitions. Well, it has interface definition, but interface definition can consist of several parts. Telemetry, property, command, relationship, and component. So commands are not implemented right now. So that's a missing part. Properties, arrays are not implemented for properties. Like geotypes are not implemented because they use properties. So because they use arrays. So my wish list would be to implement all of these kind of lacking features. Integration with IoT Hub, right? How hard would it be for Digital Twins to have out-of-the-box integration with IoT Hub? I think that's only natural, right? Don't you guys agree? so that we don't have to pipe data into digital twins using a function. And similarly, couldn't we have integration between digital twin property update and device twin property update on the IoT Hub side? Wouldn't that be great, right? So, but I know for the fact some of the work is already happening. So again, we can be hopeful that we will see some of these features support soon. Published ontologies, the two published ontologies, the quality of the ontologies varies, but again, this is just the first draft for the ontology, so I'm sure it will be improved. So I'll give you an example. So if we are, let's talk about DTDL some more before we talk about the ontology. So yeah, I think this is actually interesting knowledge that that belongs in this talk. So interface can contain the 5 type of entities: telemetry, property, command, relationship, component, accept command. So let's start with that. Telemetry. This describes the telemetry that a digital twin can emit. Now think about it. Digital twin does not emit telemetry. Your device emits telemetry, right? So there is one capability that you can kind of fake emitting telemetry on behalf of a digital twin. I'll show you how that works. Okay, so that's query. Yeah. So this capability exists in both CLI and REST API. So you can say emit telemetry on behalf of the twin. So there's no way for the twin itself to emit telemetry. You can do that on its behalf, which kind of makes sense. Telemetry is not persisted in the twin. Twin is not interested in the telemetry whatsoever. So I can see how twin may belong in DTDL model just for kind of documentation, kind of documenting what kind of telemetry it can emit. But when you're working with the twin state, you will use properties most of the time. Property. So I think this is pretty. So I'm not going to go through all the documentation, but no. Command. So an example of a property it's pretty self-explanatory. You give it a name, a type. You may have a semantic type expressed in its own semantic units. Also an interesting feature. But properties is what you will work with most of the time. What else? Commands, not implemented. Let's forget about them. Component relationships. These describe all the possible connections between different twins that you can have. That's important. Lastly, component. That's the interesting part. This allows you to include other interfaces inside of your interface. So how it looks is we will see example here in the interface. Here. So it can interface can include telemetries, properties, and they can also include other interfaces by using a component. So this is not the same as just including subtypes, properties of subtypes. If you want to use it for this, that would be a mistake. There's different capability for that, where an interface can define a type and use it for various different properties. So, like for example, it has these schemas, interface schemas. Here's how it looks. You're defining the interface. This is the contents of the interface. It has telemetries. And then you're also defining a few schemas as a part of that same interface. And you're defining the complex object, and you give it a name, and then you can reuse that type in your interface. This is how you can reuse the type. Basically, component is not a type. So this is that's different, because the way to think about a component is, let's imagine that you have an IoT edge device. Components would be equivalent to modules, to edge modules of the device, or non-edge modules, just modules of IoT device. They are kind of self-contained, right? Whereas the rest of telemetries and properties would be just the regular device properties and commands. So yeah, so what I mentioned here about the ontologies is there are examples of incorrect usage in those ontologies. So, like for example, street parking. So this is the interface for on-street parking, and it uses these as components. Like for example, maximal outside. These are just properties. These should not be components because they are not independent. Allowed vehicle type, this and that. So anyway, based on these shortcomings, I consider taking a wait and see position and just wait until digital twin matures a little bit more before I use it in my IoT solutions. But definitely it's now a good time to start experimenting. So if you haven't looked at it yet, definitely do start looking at it. Serverless pricing schema is friendly to experiment with when you're doing it small scale for your prototyping. Yeah, and let's look to new updates for digital twin service. I'm sure maybe some new updates will be announced at the upcoming build. So yeah, with this, I will invite your questions.
That's very good. Thank you very much.
All right.
Yeah, I mean, feel free to take yourself off mute and ask whatever questions you like, and I'm sure Andre I'll be happy to answer them. You're blowing them all away, Andre. That's what it is.
Everybody's asleep now. What is it now? After midnight there?
It's 8:15. It's not too bad.
All right. So maybe show of hands, who already used digital twins, guys?
not in production?
I mean, there are production deployments. If money is no matter, it's your money.
Yeah, there are quite a few sort of showcase companies that Microsoft roll out their digital twins offerings, and obviously they're the companies that they've been working with to develop these solutions. So I kind of get driven by probably 5 or 6 big companies.
Mm-hmm. More questions, more demos, more anything that
I've got a question, Andre.
Please.
Very interesting. I used to code in C++ about 2 decades ago, so I'm kind of a bit out of touch with the new advancements. But in terms of the pricing, for instance, if you were to give it to the related to say a smart city or any kind of a building, or how would that translate into the real-time costs?
So that largely depends on how much queries you're running, because like we saw, queries can get out of control pretty quickly, and so and especially if you remember that from Anton's demo, those updates to digital twin, they are event-driven in nature. They have cascading effect, right? One twin update property of other twins, and those events will trigger further updates of other twins and so on. So, and at every step of the way, you will be running queries because you want to take advantage of those relationships, right? So it's like, I would struggle to estimate that. It can only be estimated on the implemented system by running load testing and price measurements. But it can get expensive.
Sounds like a fortune to me.
So yeah, I mean, think about like Cosmos DB. Let's say you're provisioning 1,000 RUs of Cosmos DB. That costs like less than $60 a month. 1,000 RUs means 1,000 RUs per second. So let's calculate how much this would cost. 1,000 requests per second in a month. We have 2.6 million seconds in a month, which means that for our $60, we're buying 2,600 million requests. So in digital twin pricing, 200, okay, let's see. 2,600 million operations, you multiply it by 2.5, that's going to cost you $6,500 compared to $60. That's over 100 times more expensive. It's very expensive.
Okay, thank you.
But I mean, I take it as a hint, kind of like if you want, kind of Azure tells its clients to kind of be cautious using it under high load, maybe because they're still kind of testing the digital twin service behind the scenes. So I'm sure as Azure itself gets more confident in its service, it will lower its prices and it will welcome more load. So that's why I said I take a kind of a wait and see approach to this. It's kind of like the same as The new Windows update just released 21H1, right? And I'm itching to install it on all my computers, but my better sense tells me to wait a week or two. You know what I mean?
I think, as you say, with the amount of users, it's gonna obviously drive the cost down, and eventually there'll be a hop. I'm not sure how can you negotiate with Microsoft on these things, but I think eventually the buying power of many will drive the prices down.
Yeah, and typically Azure services, they do have significant discounts for committed usage. Let's say if you buy like 3 years worth of digital twins committed usage, you will get like 99% discount. No, not, but maybe like, okay, let me show you. Cosmos DB has significant discounts. Where is that? For committed usage. So let's see. Provision throughput and then reserved capacity, right? So if you commit to 3-year term of using 1 million RUs in multi-region, right, configuration, you will get a 44% discount. So that's a sizable discount. Still, you're going to be paying like almost $800,000 per month. But if you need that capacity, and if you know that you have load to consistently take advantage of that capacity, that's a sizable discount, right? Cosmos DB doesn't have the reserve capacity. Digital Twins doesn't have reserve capacity yet, but I'm sure it's only a matter of time.
Thank you.
So interesting comments. Wait until at least 2 patch sets. Yeah, it's like the old rule of start using Microsoft products at version 3. So because like Windows version 3 is the first successful Windows that that became, for example. I don't want to be cynical and whatnot, but in this particular case, I think it totally makes sense to wait for the service to be mature, a little more mature.
Andre, would you say that the query costs scale fairly, or would you be better off doing simpler queries and then aggregating locally in your own code functions, or would you then be undone by the costs of operational costs and message costs?
So the problem is that it's a bit opaque. It's one big unknown how it's gonna scale, right? Because if we know that we have indexes, then we can make certain assumption, and then we can tweak the indexes even further to fine tune it. But in this case, in case of digital twins, we don't even know if we have indexes at all. And the fact that the query units kind of scale so quickly, it indicates that the indexing is not extensively used in those queries, if it exists at all. I mean, what can we do? We can write a feedback to Microsoft and ask them to give us a more predictable query unit usage. But yeah, that cascading nature of the updates is will kind of balloon. I think they are meant to be used in this cascading nature, that this is how a programming model, that simplifies a programming model when you, at every step of the way, you're doing the event-driven style and you only have to think about how to react to this particular event, rather than, oh, I need to like do a transactional update on all its children and whatnot. That's complicated. So I think it's meant to be used in a more granular fashion, to answer your question directly. But when you do that, try to do as much a direct operations on digital twins as opposed to queries. Although you cannot avoid queries, I think, completely, because that's where kind of the power of relationships come in. So yeah, just be careful with those queries, especially multi-level ones.
Awesome stuff. Really interesting.
Okay, I hope I encouraged and inspired you to use start playing with digital twins, guys.
Yeah, excellent. I mean, if you're interested, then there's Benjamin Carbe, Cliff Aegis, and myself today. Workshop with digital twins. Benjamin's workshop over 3 episodes. It's on YouTube. If you go to my YouTube, you'll find that on there. And we hooked up a LoRaWAN gateway and a Things Network server, and got that all hooked up all the way out to a Blender app with live temperature and humidity readings from these sensors. That was a cool demo. But it was awesome to see a more real world example of where this is being used, and then to get the feedback there of where the limitations are currently as well was very useful information.
Yeah, and we're just kind of scratching the surface. We're still kind of learning to work with digital twins. I'm sure more nuances come up. Like, one thing that we didn't even touch is service limits, right? And we know that in IoT Hub, for example, those service limits, they definitely drive your architectural decisions, right? So I'm sure the same thing will happen in digital twins as we kind of get more familiar with their usages in particular solution scenarios. Yeah,
that's true. And that's, some of those numbers were quite scary when you started multiplying things up. No one wants to be paying $800,000 a month. That would be bad.
Million RUs, yeah.
Yeah. Oh, geez. No need. So so I think probably at that point we'll call it a night, I reckon. That's been fantastic. Really appreciate Andre and Anton taking the time to give us the talk. Don't forget, next month we've got Mike Pound coming along to talk about how to break an Enigma machine, so something completely different. And if you want to do a bit more IoT chat, then Tuesday night at 9 p.m. GMT, Cliff Aegis and I will be running IoT Live and chatting through some content there. And then Thursday, potentially, we'll be carrying on with our NVIDIA Jetson workshop. So, plenty of things to look forward to. And again, if you've got any interesting 10-minute lightning talks you fancy giving at .NET Knots on Monday, then you're more than welcome. And other than that, just keep an eye on Meetup for the next one.
Thanks,
so,
Pete.
Yeah, round
Thanks
of applause
for
again
inviting. Thanks for inviting us. Good, appreciate it.
Yeah. Awesome. Yeah, excellent stuff. All right, we'll catch you again next month. Cheers,
Thanks,
everyone.
See you guys.
Bye.
Bye.
See you later. Ta-da.